Hello, I am Shakti Sachinta. My index number is 17001501. To this pedestrian and vehicle detection uh, assignment, I have used Yolo version 3 with OpenCV in Python to build to run the algorithm. I have used OpenCV. First, I have this captioning. I imported a video file, this sample video before is the input file that I have used to used as the input for the deep neural network. Uh, so this is the target height and width, YOLO requires to feed the rectangular image. So one by one. So this is the confidence threshold, and this is the so the outputs will only be bounded box will only be drawn if the confidence is above 0.7, and this unmet suppression threshold is 0.5. So in here I have imported the class names which are already defined in YOLO. So there are 80 classes, like 80 different objects can detect. So I have a file name, names, which contains all the class names that YOLO can detect. So yeah, as this classes already contains person and some vehicle types, we don't need have to train the network again to detect pedestrians and vehicles. So we can use the pre-trained weights for this. So apart from this nine classes, the rest are useless for our project. So in later step, I will remove the classifications that are done to these other classes. Yeah, so I have downloaded the YOLO weights. Here I'm going to use this YOLO 320 version because this 60 it is more accurate, but its frame rate is somewhat low. And YOLO time is it's really fast, but we have to fit small images, like its accuracy also uh, somewhat low, but it's really speed. It's no time. So this 320 is the average one. That's what we are going to use in this. So I have imported these model configurations and model weights. So in here I have this OpenCV to run this to load these weights and deep neural network. So this OpenCV already have this function CV to the deep neural network, read net from darknet. So it supports this darknet, the darknet to load the darknet from these model weights and model configurations. So in here I have set the preferable backend as CVB backend queue. So in this machine, I have a MacBook Pro. It doesn't support this queue acceleration, but I have another Windows machine with a NVIDIA VGA card which supports queue acceleration. So in that machine, it will run the DNN with this queue support. But here it will fall back to CPU. So these are some random colors I'm generating to create for the bounded boxes. Okay. So this is the main loop. So here this cap.read means it will read the frame from the capturing device. Here I have set the capture as a capture to a video file input. So this image variable we get the captured image, and from that image variable, I'm building a blob to feed uh, the Yolo. So here this CV2 DNN blob from image function will create a grayscale version, scale square version, like one by one image. Uh, Here we need to input the image and with height, and this mean variable, which means it will use to here I have set it to 0. If I set this to some values, it will like try to use some colors. So here I have the variable set RB to set the RB channels. So I have set the to crop the image. If the image was is cropped, we have to calculate some other calculations to this bounding boxes. Like it will move some pixels a bit to the left or right. Then I'm feeding this log to the uh, net. We have created the net here. That means this dpl vector. So after feeding that, it will run the classification, and here we are going to get the layer names, and from that layer names, we are going to get the output layer names. This Yolo has 3 output layers. The first one is for first layer device the grids for larger chunks, like it will use to detect larger uh, features. The next second layer is somewhat small, like a small grid. The third one is the smaller, like very smaller grid. It will classify the smaller objects. So here I have done is mm, take those output layers and forward it to the network, and I have taken the outputs. Uh, this output contains those three output from those three net layers. So here, uh, this row box function, this is the function that draws the bounding boxes. So that I have to pass the image, confidence threshold, and the NMS threshold. Uh, Here I have only passed the output from 2 layers. Like I have skipped this 0 layer because it only creates some larger larger objects. So like I have run it several times. I checked that it is not making any difference. So I neglect it and send down the below 2 layers. So what is nice. So this row boxes function will draw the bounding boxes. Um, Here I'm taking the height and width from an image shape. So here I declare some empty arrays with bounding boxes plus additional confidences. Uh, so so this for each output in outputs, like these outputs only get now 2 layers, 2 output layers. So each output contains detections like a array. So array of detection. So I'm going through its detection, and I'm getting only the so this detection in this detection array. The first 5 elements are described in the bounding box, like center of the bound coordinates of the center of the bounding box, and the height and width and the class percentage. So So to get this scores for the each class, I'm getting I'm slicing the array from 5 to 13. So 13 means we only need like up to this board. So 5, 5 and this 5 to this 8 element means 13 here. So we are only taking necessary classes, and I'm taking the maximum score, which means max prediction. So this will return the index of the class, and so we are getting the confidence as this course class ID means, and this is course I'm getting the its score value confidence. So if the confidence is above the confidence threshold, which is written as 0.7 here, it will try to draw rounding box here. So this is the center x and y coordinates of the box. It contains in this detection array 0 and 1. So we have to multiply it by width and height, because this detection 0 is presented as a percentage, like 0 point by a percentage of 100. So we have to get the actual array, we have to multiply it by the actual width and height of the image to get the coordinate. Yeah. And same to the width and height. This to get the center xy coordinates. And it also contains the top and left coordinate as well. And here I have in the class ID, it's class ID to this class ID is list, and confidences to the confidence array, and bounding box is left of width and height variables to the bounding box. And this cv2.pnn.nms boxes, this is the non-max suppression function which comes with cv2 in build. So it will choose the best bounding box using this non-max suppression. So here, this in these indices, it will contain all the boxes that we need to draw. Uh, so we are taking one box at a time, and uh, unload its xy coordinates and the width and the height. Xy means center coordinates, and so the cv2 rectangle function will add a rectangle to the image frame. So we have to pass the image center coordinates and width and the height. It's not the center, it's actually the xy and the opposite of that, like in the let me draw a rectangle like this. This one, this coordinates xy and the plus w and y plus h. So here I have choose the color from the render generated color array, and this is the thickness of the border. And we say here we have the class text. This is the text we are going to put class name selected from that loaded class name array, and confidence it in this confidence array. This is where we are putting that label. This is font. This is the scale. Uh, this is the color, the same color as this. This is the thickness of border. So that's all for the draw boxes function. Yeah, and that's all for the code. I will run the algorithm and see. Uh, yeah, so we get a message that uh, DRAM module is not built with CUDA backend, so switch into CPU. Let me share the run. Yeah, that you can see it's detecting objects, but it's somewhat slow, like it needs much processing power. Therefore, it's very slow. So I switch it back to the DN, sorry, to CUDA with the CUDA acceleration. I'll stop this share and start from my Windows machine. Here you can see it's somewhat comparatively speed to the one I did before. That's because it's using CUDA acceleration. Uh, to do that, I had to build this OpenCV library entirely to support CUDA. Rebuilding uh, CV library, and it outputs a mm, Python library to import in this Python program, which supports NVIDIA CUDA acceleration. I'll show that it. Mm, yeah, you can see that it's the target backend is CUDA, and we don't have that previous error here. That's because it is using the GPU acceleration. Let me show you the acceleration here. It is the NVIDIA GeForce activity display. Here we can see the Python exe is uh, powered by the GPU, and in task manager also you can see it's this is the application. It's utilizing the NVIDIA GPU. Uh, Performance also. The utilization is somewhat low. I don't know whether it's Shanghai's issue or something, but it's really using the GPU to accelerate the performance of this uh, channel. So that's all for the presentation. Yeah, and thank you.